Welcome back, Ms. Patricia and Mr. Marco, again in to trust me on the another course. Basically, yesterday I have delayed the class because at that time I just enrolled the three persons, uh, two from you and from my uh, colleague. He has joined me. So that's why I have delayed the yesterday class. Maybe someone will join, but I'm not succeeded to join another person. So no issue. We will continue our classes. Uh, if you have any previous uh, classes issues, you mostly ask me in the group, but if you have any suggestion for this session, you can tell me. Then we will start our today lecture. Can you hear me? Okay.
Yes, we can.
Okay. Thank you, Miss Patricia. If you have any suggestion, you can tell me. If not, then we will start.
Okay.
Okay. Just sharing my screen. Can you see the word file? Uh, okay. Basically, this file I have ready, prepare for all of you. Uh, Basically, this is the report I have prepared to tell all of you, and then from that point of view, we will move on to the uh, next step. First of all, these are the four main, like four part of the same IC standard 62305, and then the IC 62561-2. Basically, these are the main IC standards which will be used in the lightning protection study. So, first is the first part is basically give the general like the overview, and then the main preparations like this type of work will be done. And then in the next part is related to the management systems. And the third part was the physical damage to the structures and life hazards. And fourth part is related to the electrical and electronic system within the structures. And the other IC standard, which is related to the uh, uh, component, like the conductor size, the cross-sectional area of the structure, which we will use for the path from the lightning current to follow through this path and to be grounded. So in this standard, there are different requirement are mentioned. So we have to just follow these requirement, and then we can say that uh, it will be okay, and we can uh, install the lighting protection system on the structures. Like if you see in the solar power plant, like on the large scale projects, we have to do different things, like we have to install the finials uh, on the mounting structures. But the issue is that when we have to install the lightning protection on the systems, we must have to follow the IC standard, and this IC standard will give us the way how we can install the lightning protection systems on the mounting structures and around the different in the electrical systems. So we have to follow these four main five standards. Then it is the introduction. Ba- Basically, atmospheric electrical activity and especially cloud to ground lightning poses a risk to the person, structure, and equipment. International standard IC 62305 lay down the risk calculation depending on whether the lighting strike the structure directly or indirectly. Distinguish four possible sources of the damage or harm. So basically, when the atmospheric electrical activity and especially the ground cloud to ground lightning causes a severe risk to the persons, mainly the person structure different equipments. They will create issue, and they will damage the structure. They will partially damage the structure. They will due to that mostly people will die, or some cases it they may be somehow damaged, somehow burn due to the lightning current and other equipments, mostly the inverter and the stations, cables, somehow different equipments will be affected through these lightning strikes. So this IC standard 62305-2 will weigh out that how we will calculate the risk assessment. What type of risk available in that area where we are installing our electrical system and our uh, solar power plant. So then on that basis, we will check whether this risk is under the limited value as per the IC standard, or it is higher than the calculated value of the risk is higher than the limited or tolerable limits. So if the risk is higher than the tolerable limits, then we must have to go to the lightning protection systems. We have to install the lightning protection systems. Then we have to do different calculations. What type of lightning protection system we have to give to our systems. There are the four classes of the lightning protection system. Fourth, third, one, two, and one. First one, class one, is the most expensive part, most expensive protection system. Then lower than class two, then class three, and then fourth. Lowest class is uh, class four, which is cheaper, but the risk of lightning is higher in that case. But they will protect our solar system. If the risk is in the small values, then we have to give the class 4 protections. But if the risk is on the higher side, then we have to go to the other classes like class 3, class 2, class 1. But if there are the most severe cases that we have to give the class 1 protection, mostly in the PV plant, solar power plant, we have to give the class 4 or mostly class 4. Somehow maybe we have to go to the class 3 or class 2 due to the like higher side of the area where we are installing. Like I am experience this issue. We are installing a 620 megawatt solar system in South Africa, and the area of the solar power plant is much on higher side, and there are four transmission line passes through that area. So um, like 2 to 3 days before, I have started work on that lightning protection study, and I face that level 4 protection is not suitable for that area. Then we have to give another solution, like we have to go to the light class 3 protection or class 2 protection, or maybe we have to divide that area in different chunks to satisfy the class 4, because in the solar power plant, the area is higher on the higher side. The lightning protection, lightning finials, and the amplification lightning arresters and the conductors and the other parts is on higher side. So the cost is very high. So we have to try to limit the uh, the class 4. We try that our risk will be in the go in the tolerable limits, as when we give the class 4 protection study. Now we move on to the next. Now, the procedure for deciding the need for the protection and for the selecting the protection measures. Now, we are moving to ahead to whether the system, or whether the solar power plant and electrical system, whether it needed the lighting protection design, protection study, or their risk is in the tolerable limits. So now we are moving to the these steps. This is basically the procedure we have to follow. First of all, identify the structure to be protected, identify the types of loss relevant to the structure. For each type of losses, identify and calculate the risk component R A, R B, R C, R M, R U, R V, R W, and RZ. First of all, we have to identify. There are the four type of structures. The losses type, damage type. Like if the light strike directly on the structure or near to the structure. The first is directly on the structure. Second is the near to the structure. Third one is the strike flashes to the transmission line or near to the. Fourth one is the near to the. So we have to identify this version. Like I will comments and that. Yes. So we have to identify. Parking is available. Yes, annotations. So here basically this is the identify the structure to be protected. Then identify the type of losses relevant to the structure. There are the four types of losses. So we have to check which type of losses is relevant to the our solar plant and our calculations. Then on that basis, yes. Then on that basis, we have to calculate the R1 component, RP, RC, RM, RU, and so on. Then we will go to the next step. If on that basis, on the this basis, RA, RB, RC, RM, RU, RV, this component basis. If the risk, total risk calculated, we when we will move into the next step, we will see that from these component how we will calculate risk for risk R1, R2, R3, and R4. If the total risk is higher than the RT. RT basically tolerable risk limited. If this is higher than, if yes, then protection needed. If no, structure protected, no issue. If protection needed, is LPS installed? Yes, no. If yes, are search protection measures installed? Yes or no. These are the process. If is LPS installed? No. Are A plus RB or U or C greater than uh, RT? Yes. If yes, install an adequate type of LPS, uh, light protection side devices like lightning arresters. We have to install. If this risk calculation is higher than this, we have to install the lighting protection. But if this is less than the tolerable, no, installed at from that option from the above. Are such protection measures installed? Yes. Install other protection measures. No, install adequate surge protection measures. So we have to install either we have to install the lighting protections or we have to install the surge protective devices. So if this is okay, then uh, calculate new value of the risk component. If these are like we have to install the lighting protection systems, then we have to calculate again these components and we have to check whether it is okay. Then we will say that our system is protected. Then we will move to the identifications of the structures to be protected. Structure length and width considered in assessment. Basically, I have considered a PV plant. The length will be the 1280 meter and 880 meter is the width of the whole power plant. Like I will mention that in that area. Yes. Like here is the area. I will mention this. This is the length, this is the width. I have just calculated this total area. Now we have considered that in that area, what is the maximum height? Like in that area, there are the multiple things installed in that area, and we have considered the maximum height. Like in the solar power plant, the maximum height of the MV station is 5 meter, or weather station height. So we have considered that one, because the other one are the lower than this value. Like weather station height is 5 meter, MV station is 4 meter. Like this height is 4 meter. So we have considered the highest this height. So for other, we don't need to consider the lighting protection, because if this criteria is satisfied, then they are all in protected in that area, in that zone, which are protected from the lighting protections, lighting flashes. So for that reason, we have considered the 5 meter height, because in our solar plant, which I have considered as an example for the calculation purpose, uh, all the heights are on the lower side than the 5 meters. So we have considered that highest height is the 5 meter. All the equipment structure in the PV area are different heights and sizes. Instead of performing risk assessment separately for each component, the overall maximum height of the structure is considered at 5 meters, uh, so that issue and issue something. Okay, okay. So these are the equipment installed in the PV area. String inverter, steel structure, mounting structures, galvanized steel, MV station, metal containers, PV module installed in the structure combustible, DC string cables, low flame, non-combustible, LVAC cables, combustible, MV cables, combustible, communication cables. These all are the equipments installed in that PV area. So in the assessment study, the overall height of the structure is considered as 5 meters. Thus, all the above equipment within or below the 5 meter height shall be considered as a assessment uh, assessment for that area. Because if we consider the lowest height, like we can see that the string inverter or LVAC cables are on the ground levels, like the cables are on the ground level, and we have considered that height. But from the above height, all the cables, all the other equipments are not safe. They are in the zone or where the light should be flashes. So we have considered the height of the 5 meter, which is higher for the like the MV station is installed at the like 3 meters. Like weather station installed on the 4.5 meter and around 5 meter. So that's why we have considered the highest height. So if we can consider the other lower limits, but we have to consider the assess all the the other equipment which is on the higher side, and they are not protected through this assessment, we have to consider the other assessment for that specific equipment to install the lighting protection on that specific equipments. So that's why we have considered the 5 meter height. Then the overall area is protected through these equipment lighting protection study. Then then move on to the next step, which is related to the identification of the sources of damage, type of damage, and respective loss type to the yes, Miss Patricia, go ahead.
A quick one. The 5 meter height, you've also taken into consideration the terrain of or the land, because at times maybe if the land is not flat, you might have higher areas.
Yes, yes. Because maybe that chances that we have to consider the height of the total from the ground level. So, like in the mountain hill areas where the PV plant is installing, and in that area, maybe chances that the PV module is on the higher side and the MV station is on the lower side. So we have to consider this also. And also, we will see in the next calculation that the lightning strike per area, in that area where we are forming the assessment, we have to consider that. So we have to consider the hill area, like the other options where we are installing our solar power plant, because in that area where we have I have considered, it is in the mining area, and it is on the mining depths area, and the client has uh, uh, level the ground level. They have laid a one like 500 thickness of the calculate layer of the so that's why this area is totally flat. So we have considered the like 5 meter for that area. But for the other area, like for the other area, like where are the solar power plant area installed in the hilly areas and the other areas which are not on the equal side, so we have to consider that in our assessments. So we will move on to the next step. The other one is the identification of the sources of the damage, type of damage, and the respective losses, loss type to the structures. Now, according to the 62305-2-2010 table 1, the sources of damage possible lighting strike point and the resultant damages and the types of the losses are given below. Now we can see that there are the four types: flash, lightning flash, point of the strike, where they are pointing, like you can see that. You can see that uh, they are, the point of strike is uh, exactly on the structure or the buildings. This one is called the source of damage is S1. And the types of damage, these are the three types: D1, D2, D3. These are the three types of damages. And the types of losses: L1, L4, L2, L3. These are the losses types, structure losses type. So we will see in the next lectures. These are the losses and their calculation, and also. So the next type is the flash, lightning flash near to the structure, not actually on the structure. Near to the structure, they will flash. The sources of damage is called as 2, and the type of damage is just D3, just D3, and the type of loss is L1, L2, and L4. The third one is the case is that the lightning flashes strike to the actual transmission line, RTL line. So this is called the S3, and their damages are same like the one D2, D3, and the same losses types. And the fourth one is called the lightning flash strike to the near to the transmission line, and then the same D3, D4. So these are the four types. When we have to calculate these sources of damage, then these sources will create the same losses, and then we will see our calculations. Basically, I just want to give the overview of that sources of damage and possible lightning strike points. So we have mentioned that the S1 is flashes to the structure, S2 is the flashes near to the structure, and S3 flashes to the line connected to the structure, and S4 is the flashes near a structure connected to the structure. So then we will move on to the damages. There are the three type of damages we have seen in the above pictures. This one, D1, D2, D3. Same one is a D3, D1, D2, D3, and these are the damages. So these damages D1, D2, and D3. D1 is basically harm to the living beings like humans which are working in that area. They will be affected through the lightning strikes. This is called the D1 damage. Then the second damage is the physical damage, like the structure and the other damages will do. And the third one is called the failures of the electrical and electronic systems due to that flashes. So these are the three type of damages will be done through this lightning flashes strikes. So from that damages, we will see the losses. There are the four type of losses. We have seen that there are the four type of losses: L1, L2, L3, L4. Like same, you can see that. So there are the four type of losses. Depending on the above type of damages or harms, the following type of losses may be occur to the class 4.1.3 of the IC 62305-2-20110. As per this IC standard, we will follow we will face these type of damages. L1 is the loss of human lives, including the permanent injury. Maybe they will die, or maybe they will be permanent injured due to that lightning strike. The second one is the loss of the service to the public. Maybe there are the service like the electricity. These are the service provided to the publics, and this will be damaged through this lightning strike. And the third one is called the L3, loss of the cultural heritage. Maybe there are some cultural heritages present in that area where the lightning flashes. So due to that, this loss may be occurred. So this is called the third one. So when we will see in the PV area, we will see that either these are the cultural heritage is present in that area. If the cultural heritage or some no-go area is present in the solar power plant, then we will consider this loss in our calculation. But if they are not present in our solar power plant, then we need to present, and we just mentioned that as per the IC standard, these are the cultural heritage laws, and there are the no cultural area in that our power plant. So we don't need this loss. And the fourth one is the loss of economic value, like structure, content and loss of activity, maybe different things like structure is lost, damage. Due to that, the electricity will be lost because when the structure is damaged, the solar power plant is damaged, and like the area. There are the loss of activities due to that. These are the four type of losses will be occurred in that due to the above three damages. Then we will move to the risk due to the lightning strike. Above losses, damages, and type of damages calculation are further used to calculate the risk. Based on the 62305-2-20110 section 4.2.1, the composition of the lightning risk component for each type of loss is as followed. Basically, these are the four risks, four losses. These are the four losses. Like same one, we have four type of risk. One is for the loss, or one is for the loss of human lives. R2 is the risk of the loss of service to the public. R3, the risk of loss of the cultural heritage. And the fourth one is the loss of economic values. These are the basically the four losses. From that, we have to consider the risk. Either this risk is present of the losses or not. We have to consider this and we have to calculate these losses risk. Then on that risk basis, we will calculate decide whether we need the protection system or we don't need to give the protection system for our solar power plants. And then the damage probability. For understanding purpose, short detail of the probability. Basically, uh, in case of the direct light strike to the structure, we can see that above. You can go above, like in that area. So, as per IC standard, these are the probabilities, chances. What type of chances is available in that area? On that basis, on that chances basis, on that probabilities basis, we will decide whether it is risk is present in that area or not. In case of the direct lightning strike to the structure, there are three type of the probabilities in PA, PB, and PC. Injury to the living being by electric shocks. One is one, the injury to the living being to the by electric shocks. PB, physical damage, fire like the explosion, mechanical like chemical reactions. And the third one is the PC, failure of electrical electronic systems. First, A is the injury to the living beings, PB, physical damage, and the third one is the failure of electrical electronic systems. In case of lightning strike to the ground near a structure, PM, failure of electrical electronic systems. For that, this will be called as a PM. For the above, you can see that the PC, failure of electrical electronic system. When we see in the case 2, like flashes near to the structure, it will be called PM, failure of electrical electronic systems. When the third case in the of a direct lightning strike to an incoming lines, PU, PV, and PW. Injury to the living being by electric shocks. Some people are working in that area, and it may be chances that the lightning will be strike on the transmission lines, which will be connected to the structures, and there might be chances that the electric shock will be uh, uh, to the persons, and they will be there might be chances of the death of the people, and might be chances of their permanent injuries. So first one is called the PU, probabilities. The second probability is the physical damage, fire, explosion, mechanical and chemical reaction. and the PW is called the failure electric electronic system. Same like that. The above one, yes, they give the names, but their formulas are different. We have to calculate all the values for every component. We have to calculate basically the lightning strike is the calculation process. We have to do the proper calculation step by step. Then we reach out at the point where we will calculate our risk. But uh, in the last class, I will show you a online website is available, which will give us the somehow calculations. But most of the client consultant will not accept the calculation of that website. So we have to do the proper as per IC standard calculation, like which I am showing to you in that class. And the fourth one is the lightning strike near to the incoming lines. PZ is called the failure electrical electronic system. Some of the probability related to the risk components with the line are just shown above for understanding. So these are the probabilities options like PA, PB. We have to calculate these, and then we have to calculate the components, and then we have to calculate the risk. So lighting protection measures. When carry out the risk assessment, reducing the risk of the damage or harm caused by the lightning discharge, two type of protection measure are required, and which are one is for the external protection, the other one the internal. Basically external, which we are give the lighting arresters, like the lighting rods we will give in that PV area or in our electrical power plants. I leave that today meeting due to the family issue. And the second one is internal protections. Internal protections. Basically, the internal protection which we will give the surge protection devices in our systems. Like in every station, there are the type 2 and type 1 surge protection devices present. In inverters, there are the type 2, mostly vendor will give the type 2 protection devices. And combiner boxes, like there the internal surge protection devices are present. So the purpose of the purpose of the external lighting protection is to capture and channel direct lighting strikes safely, conducting the discharge to the earthing system and through protecting buildings, structure, and peoples. So the for the external systems, they will capture the lightning strikes and ground to the through the earthing mesh to the ground. And the purpose of the internal lighting protection is to safeguard PV component like infrastructure and occupant within the structure from the damage effect of the lightning strike. It achieved this by providing a low resistance path for the lightning induced current to the safely dissipate into the ground, thereby preventing injury, fire hazard, and other issues. So we will give the this internal protection devices and also the external protection for that lighting systems. Then we move on to the frequency of the lighting strike NG. Basically, this is very important. When we are calculating our risk assessments, we have to check how many strikes NG 4 point, like in that area where I have calculated this. I have checked the South African standard. Basically, I will check again for the other countries. which are the standards which will give us this calculation values. But in the South Africa, this is the standard sense 10313 2018 and XUC, the lighting ground flashes density NG, 5.4 strikes per kilometers square per year are considered in the risk assessment calculation. Basically, where I have calculated this risk assessment, in that area, 4.5, 5.4 NG value, lightning ground flash density value. So, but for the other countries, we have to check again. I will search again what are the local standard will give us the this value, or any IC standard will refer for that. I will check again and will tell you in the upcoming classes. So now we move on to our risk assessment calculation. The risk assessment calculation of the risk components like RA, RB, RC, RM, RU, RV. These are the components on basis of the probabilities, like the same one we have to calculate it. So here is the formula for the risk assessment calculation. Rx is equal to Nx, Px and L. Basically, P is the probability, L is the loss, and R is the component. Like Ra is equal to Na, Pa, and La. So X is like for the same purpose we have used is N is the number of the dangerous event per annum. We have to calculate these values. IC standard will give us the formula for this calculation, and I will tell you how we will calculate this calculation. And then the probability, damage to the structure, and this the losses. So this is the process we have to follow. Uh, this is the process. I will continue this class tomorrow. From that, uh, basically, I will share this document with all of you in the group, so you can study this document. And if you have any questions, you can ask me. And if you have any specific region, we will calculate our risk assessment. If you have any question, Miss Patricia, because Mr. Marco has left the class, you have any question, you can ask me. If you don't, we will skip our class and we will continue our process in the next. Yes, Mr. Patricia, no issue. You can ask.
Okay. Yeah. Okay. Thank you for the great class and the introduction. I'm just wondering, for this, the IEC standards, are they freely available or one has to purchase them? Because I think I would really want to have a copy. And then the other one, in it's what you have said. My question was on risk analysis for a specific country and the parameters to use. So I will check what you have, maybe the one you have for South Africa, and see if I can compare it, if I can get the answer for my country. Thank you.
Okay, Miss Patricia, basically, I will share this document in the group. You will study this, and the South African standard, which I have mentioned, 10313. You can check that. I will send because these are the standard are the purchase one, and I have their copies. So I will share with you in the group, so you can study these standards. And for the South African standard, I will share also with you. You can check again for the local standard from your side. Maybe you have to search for that.
Yeah. Okay. Thank you very much. I'll appreciate the standards. Thank you.
Thank you. Okay, okay, Miss Patricia. We will meet again. Sorry, I want to tell you that tomorrow maybe we have to skip the class. Basically, I have some like a party with my friends. So maybe I have reach late at home, so maybe we have to skip the class. So sorry for that. I will inform in the group.
It's okay.
Okay.
It's okay.
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 Thank you. Thank you, everyone.